So good night, everybody. And so this is live coding apparently, but I'm thinking that it hasn't been live coding for a while. uh, I'm not sure if even programming. So maybe these are better suited for another title, you know, saying something like building some application instead of live coding. People maybe will click these videos, expecting some code to happen or programming, but maybe building because I am documenting the entire process as it's happening, um, just in case. Uh, mhm, yes. So this was streamed December the 5th. We have 1 week without uh, no progress in here. 1 week. Imagine that. So December 5, now 3 days here. Okay. So just a weekend. That's good. But on Friday, last Friday, we were just again tinkering, and yeah, let's put an alarm. Uh, yeah, let's open this Debian. My website. Um, oh, yeah, this is an Elixir application. So I always go with where the Elixir code is. But it's not an Elixir application. It's wrapped as an Elixir as Phoenix application. But it's just the static HTML and CSS most of the time. So that's great. Uh, mm, Geometry. And here you can see everything. There is this application that it will be some sort of metronome. I want to be a metronome. Uh, there are gazillions of online applications of metronome, but that's great. Did another one. Will be the same, but now let's focus on geometry. Will be three: affine geometry and symplectic geometry. But I'm not sure about the two others because we are having a hard time with this. Now imagine having to simulate a protractor or a compass or some other tools. Will be quite challenging, and we don't have any. This is just the time I can afford to invest on this project. You know, uh, still I can afford not to use my glasses because I am very near of the screen. But eventually, I have my glasses over here. Okay, open, and we have this. Okay, we can't pass this point. We don't know what to do. uh, so here's another outing which now we are not going to tinker with the. Let's open Visual Studio Code. Uh, uh, yeah, now I remember what. Here the brightness. I always use this brightness. and uh, dark theme. Okay, so not code. Mm. Do you trust the others? Yes, I trust me. Of course, I trust me. But there are more coding here. I trust the guys at the Elixir, the Phoenix web framework. And oh my God, look at this. Oh my God, I opened the wrong folder. Close folder. Where is it? Add folder. Say workspace. Open recent. No folder. Uh, open recent. Open recent. Say workspace. Oh my God, now what? I open everything. Close folder. Uh, so now let's switch directories. Oh my God, I opened another instance. Okay, now this is a mess. I'm going to close folder. Close code. Imagine this. Okay, it's opening the thing. Okay, static. Playground. Of course. Geometry index. So we're here. We have nothing. We got nothing. Yeah, we have been tinkering, but we cannot find a relation of the variables. We need to think a little bit more, or maybe explore the circle equation, uh, familiarize ourselves with the rotation concept at the level of algebra. Maybe I don't know. I am ignorant. Um, let's put an alarm. So it's eight, nine, 9 o'clock practical. So let's go to 10 p.m. 1 hour because it, maybe tomorrow 2 hours. That will be for this application every day, 2 hours, 3 hours at most. And it will take us forever, maybe 5 years. Hopefully not. Hopefully we get the idea behind the geometric operations and deliver this thing for people to use it if they want to learn or if they want to use it. I'm not sure. Um, yeah. All right. Okay. Okay. So, okay. So we are agreeing at the same spot. We got nothing. So we have our alarm. Let's open the chalkboard pictures, pictures of home, which is a song by Deep Purple. If I remember correctly, I know that song by for because of In My Mom's Team. No song covered by In My Mom's Team. Uh, yeah, okay, let's open this with what? Snipping 2. So okay, we can draw here. Here. Mm, okay, now we are again in the same place. We don't know what to do, but we need to get started. So we are going to draw a rectangle, uh, just like this. This is the screen, I suppose. And then we will have going back here and a little bit smaller, so we can have these things that. Uh, so this is the screen or the viewport. We are using the entire viewport, the entire screen. We cannot see. Oh my God. We cannot see this. We cannot see this. We cannot see this. We cannot see this. Okay. Then we can draw our thing, our threaded edge. Where is this thing? Here it is. Let's. Okay. So here it is. We're going to draw it exactly as it is. All right. And we have access to this point. We can calculate this point. We know this point, 0, 0. We know the width and we know the height. And we can calculate the midpoint. And we need to calculate the midpoint. We're going to try this idea for this hour, hopefully. And um, I hope my mind, uh, as the Beatles song goes, stop my mind from wandering. I can stop my mind from wandering and focus on the task for an hour. Uh, okay, so we have this one. We can calculate this one, and uh, we want to have this rotation. Uh, we want to have it this way, right? Because we say that we can rotate like this. It's not my problem. I called it a day. Yeah, here is this. Use this uh, and have fun. But I don't know that uh, I want to know how this thing is done. Okay, we are tackling for that. We can draw this thing. I'm not procrastinating. I'm trying to use my time efficiently. This week, I'm starting with a new mindset. I want to diminish or decrease the procrastination time. Well, still, I have too much to learn about time management. But I don't want to, enter into the mindset of producing the entire time. No, I'm not like that. Uh, but still, using the time efficiently is a challenge for me. Uh, okay, so yeah, we did. So we can calculate this. We're going to calculate this point. And oh my god, this is hard. This is not easy. We need also this point. So the so the rotation happens at the midpoint. But I'm not sure if we probably we want to save this image. Maybe we want to also explore this circle. There is a circle. There is a circle with radius. Uh, Maybe we want to explore that idea. There's a radius. There is a circle, and maybe we will need. Maybe it is a good idea to take note of the idea that we want to explore for a given session for an hour or 2 hours, and then in order to not to mix ideas, because now we have to like two ideas, one comprising calculating all of these points. If you have a given point and some radius, if you have a given point, x, y, this is amazing. If you have some point and a given radius r, and look at me, I am a mathematician. mathematician. We have this point xy, this point, and then some radius r. So how can you calculate all of the points that belongs to the circle or the circumference? That's one thing. Uh, we can explore that idea, which is great, but it will take us 20 hours to really get to know, to familiarize ourselves to the circle, to the point of portraying the ideas into code. And achieving a level of familiarity of this geometric figure and its related relations. Uh, after we can calculate all of these points, if we learn, maybe we can use Google for this. Nothing wrong with that, because if we need to invent the circle equation by ourselves, then it will take us like 1 year, maybe. I don't know how many time, how much time. Yeah. Uh, it took the guys from the past to come up with these things. So it's not no, it's not my intention. Every brain can produce these things, in my opinion, but it's not my intention to do it. Uh, if you can calculate all of these points, having this origin and the radius, then maybe you can find a way to translate this, or maybe this, which is the origin of the threaded edge. Here is the threaded edge, and move the thing over here, right? That's our second exploration. It will be great. Yeah, I have the geometry book. Maybe I will take a look at the geometry section from the book. I wanted to start the book once this thing is finished. Well, it will take me forever, so I better start. Okay. Now, that's one idea. The one with the circle that will be the hopefully the most uh, mm, you know, so we can stop thinking or guess and check. I don't know, as the people in the trainings said, you know, so guess and check algorithm. Uh, yes. Uh, yes. Now we are blank again. But remember, we have the constraint of the view, the coordinate system. Uh, Most of the time you get to know this, but now we have this. This is 0, 0. So things happen, and I don't know, a little bit different here. So we can explore certain things like what happens if we translate the origin uh, to this middle point. I'm going to delete the other. Oh my god, look at this. Well, okay, so we have this is the oh my god, this is the origin, and we can calculate this midpoint. What happens? I can't believe I have wasted too much time in my life. You know, this Steve Jobs said that a little bit of guidance and direction can go a long way in your life for a given. Uh, and I was very privileged to have the right parents. I am very fortunate in that regard. Met some great people, but still, I think I don't know. Maybe the sense, maybe it's what they call community. I don't know. No, that's not the case. I don't know. I don't know. So let's focus on this. So if we translate, if we oh my God, if we rotate the straight edge or the rectangle, having the origin here without any translation, we will have this thing. Okay? No, no. We will have, look at this. This is the origin. If we rotate in the origin, we will have this thing. Remember, we can see here. Look, so there, going to delete. I'm going to delete this. There's nothing. I'm going to delete the rotation comment. Now we have this model, not model, this uh, scenario. Here's, oh my God, here's the straight edge, the white rectangle. If we rotate, this is the origin. If we rotate without translating the origin, see we cannot see anything because the straight edge is here. Okay, so what happened is that this point is this point, right? It seems easy. Something in my brain is saying it seems so straightforward. Uh, it seems like that, but our brain is still are making some. I don't know. So this thing is this corner is this corner, and this corner is this corner, right? What happened is this. Now, if we translate this, oh my God, if we translate this point to here, we will have this. But in order to avoid this calculation, let's translate the point to here, and we will have this. Okay, we're going to put it at the middle, and we have the translation. Translate to y remains the same. and the rotation takes place, and we are at 0, 0, which is current x, current y. Let's actually put this. And something went wrong. Maybe we are not. This thing, I don't know if this thing happened. Mm, let's do the rotation. Mm, or the translation. Look at this. Look at this. Still, this is great. You see, now we have translated to the midpoint, which is here. And the straight edge went like this. You see, here's the space. Here's the blank space. Well, we say that we are going to rotate. Okay, and this is where we got. So this got erased, the white rectangle, and we have this. Got this. Now, if we if we if we calculate this midpoint and perform the rotation, look at this. Look at this. Okay, we will get this. This this image. So, my God, this is hard. And this is not. It does not work for every angle. It does not work for every angle. We need to familiarize ourselves with the circle. This is what's going on. Uh, this is a circle of some radius r, which is the midpoint. If we translate this, we can calculate the midpoint over here of the straight edge. The straight edge goes like this. And this is I'm hesitating to believe my eyes because there is no way that a straight line fit into a curve. You know, Oh my, if we do this and then draw a rectangle, there is no way. There should be a space here like this. So this is, I don't know how this is called, a chord. So if we calculate this point, which is the midpoint, and then we have access to this point, and we have seen that if we translate this origin to this, we end with this. We don't want that. Look, uh, so we need to, and this is the some sort of midpoint. Here it is. Here is a line, just for your reference. Okay, and we have a line here. This point needs to be here. Let's allow ourselves a little bit of something and put the point right here. This point right here. So this point, so this point will be here. This will be here, and this point will be here. And now we can draw our thing like this. Only if it is only if it is 90 degrees. Let's suppose it's 45 degrees. So it will be here. The midpoint will be here, and the other one will be here, hopefully. And the thing will go like this. Now, how can we find these points? We have, let's use another color. We need to calculate this. We have this. Uh, what color should we use? Orange? This should be here. But this is hard to calculate. Where exactly in the circle this thing is. So uh, our best bet is to translate this H midpoint, H, the midpoint of the H to the 90 degrees. By having this comes by default to this place. So our problem is given given some x given some the problem we need to solve is given this point from x prime from x prime. This is given uh, the x prime origin and some radius r and uh, some other point. So let's call this O because you know the origin, and let's call this P because that's what they use. We need to find P prime. That is P. Imagine rotated 90 degrees. P P prime is P. It's not P. P prime is P after applying some transformation, they call it in the book. Some transformation, some geometric operation. And that's why Alonso Church is saying that it says functions. He mentions, I haven't read it. I haven't finished reading his paper or his book or article, and I'm not being pretentious here, but it's reminded me that just by reading the first pages, the guy mentions that function is like some sort of a transformation, and he also uses operation. And the book is saying that these are geometric operations, and they are calling it also a transformation. So this function concept maybe it comes from geometry, but I haven't explored too much on how the guys in the past were what kind of thing they were observing, so I can observe those things on my own, as Judea Pearl says, with my own eyes, and say, oh, this concept is this. And now with the advantage of all these years, uh, say, oh, so the guys in the past 400 years ago wanted to say this because I have all the, not exactly me, you know, I'm lacking some knowledge, I'm lacking some maybe culture, I don't know, but maybe some other people in other parts, some other planets, they will, they with more information, with I don't know, more tradition on these things, uh, they will, if they go to what those guys were really into, instead of having just, you know, like, for example, me thinking that solving problems on a book of algebra make me an algebraist, is the word? That I don't think that's the way to go with algebra. I want to know uh, what those guys were really trying to see or find. Also, I don't think solving just a bunch of exercises or whatever would you want will make you into anything. I don't think that's the way of the science. But it's just me. I'm just an ignorant guy that cannot solve this this easy problem. Uh, well, yeah, there is the connection of operation is now the on the scene for me. I need to document myself a little bit more before falling asleep. Okay, we need to solve this problem. Most likely, gazillions of people, hundreds of people have solved this problem. Some high school students have solved this problem. I don't know. We're going to try to investigate in the book, geometry book, a little bit. I will document thing. I will open a session, live stream, and I will read the section with you, geometry section, the circle section, and if the geometry by itself give us the answer, we will use it. If it doesn't, then we will use some algebra with geometry. And if it doesn't, before looking for the answer, we are going to try to just 1 hour, 2 hours. I don't want to pretend to be inventing this or discovering this. It's too much pretension, it's too much. I'm not that like that. This thing has been solved. Uh, just, just to see some stuff, 1 hour, 2 hours, and then look for the answer. Nothing wrong with that. And then someone will say to me, uh, why do this? Why don't you use some artificial intelligence assistant from the very beginning? Yeah, we can do that. Uh, yes, give me some, I don't know, some prompt engineering. I don't know. I'm not in a hurry to deliver this. If you are, you know, rushing to hit the market, and then you can assist yourself with artificial intelligence tools. But I am not rushing to hit the market. Hey, here, look at this. Just trying to have some fun, amuse myself with this, and at the same time deliver this for whomever want to use it. So enough justifications and let's get to work. Enough time. So we have now we know we what to try. I'm not saying this is the solution. We want to find this point. We want to put it over here. I'm not sure what the terms are, the technical terms. Well, I want this point to be here. The equivalence, I don't know, the relation. If we have this, then we can add um, some half distance on the x. But there's another problem. If we That's for the 90 degrees. If we add this space to reach this point, which is the real origin, to perform the rotation, this will be adding on x. You know, well, it's not the case that the user will be rotating on 90 degrees all the time. What happens if the user happens to rotate 45 degrees? We will not be able to add on x. This It will not work. We will end with this. We need this point. We can use x, uh, or we will have to modify the equation, and then if the user rotates on some negative rotation or over here, it will be a mess trying to always add x. So that's not going to work. In fact, we need this point. I don't think that's quite straightforward. But we can adapt, maybe. Maybe we can. I don't know. If we find some formula to translate this point, this to here, maybe we can use the same principle to put this over here. If it is 90 degrees, the correspondence between this and this, some sort of 90 degrees. And if it is uh, 45 degrees, how can we calculate this point? So we have something to work with. Now we are not a blank anymore. I don't know if this will be the solution. We'll need to try it. So we have the origin, and we have this point, we have this point. And in fact, we have this one, but uh, we can add something here. Yes, now I think it's time for me to leave. Um, and come on with this tomorrow with the book, maybe 2 hours, 2 hours and a half. Open the book, you probably, hey, I'm reading. I want for you to see me reading. I want to document the entire thing, the entire building process. Uh, just in case someone is interested. Uh, to be more data we have, the better. Uh, the more data we have out there, the better. If the data is public, like this, I'm not putting myself as an example, but if the data is public, then some people are into some sort of that data science, sort of algorithms dealing with data can use it. Uh, as long as we respect the privacy of people. But this is public now. Um, yes, I better shut up. So okay. 70 minutes. I think we can use this time to explore the circle on Wikipedia. Circle. Maybe we will find the solution in here. I already took a look some days ago. I always put this into that. I'm not sure why. This has been solved 100,000. There are animations in which there are some clocks, even animated, some point animated. The point over here is being animated. I've seen those animations, but I don't want to see the code. Uh, First, I want to fragile. I just take a look at here, and tomorrow we will use the other book, Geometry by Geometry. Well, here we will find some formulas. Algebra includes. So the perimeter is some people like to memorize this. I haven't memorized this thing. So 2 pi times radius, 2 times pi times radius. And area, we don't need the area, most likely the perimeter. It seems so easy. The circle has been known since before the beginning of recorded history. Imagine this, and still thousands of years we are using the same concept, which is great. We are the same. Natural circles are common, such full moon, slice of a round fruit. The circle is the basis for the wheel, which is the animation for years. The city have helped inspire the development of geometry, of astronomy, and calculus. Here was the ring-shaped object. So here is diameter. A line segment whose endpoints lie on the circle, and that passes through the center. There are a lot of things. This. You can spend your entire life studying these things. So this is a segment. You have segment, but you have chord. Second, radius, diameter, tangent. This is how Euclid defines circle. Seems the guy that Oliver Heaviside was against how geometry was being taught when he was on this earth alive. No, I don't like to memorize this thing. I'm not into this. Uh, Oliver Heaviside is right. There's to say. Well, this worked for a long time, so don't hate me for this. Uh, for the time of the earliest known civilizations. Okay, so this is history, great. Hmm. The ratio of a circle's circumference to its diameter is by an irrational constant. The ratio of a circle's radius to pi. Okay. I think this will be some sort. I think the problem that we have will be in some sort of some algebra book. It will not be plain geometry like projective geometry. No, like Euclidean geometry. Without algebra because I was, um, yeah, we will need to use, we will need to translate, as this guy says, to the language of numbers, the figure to the language of numbers. This Helfand says. So maybe we will not find anything in here. Archimedes, this guy was killed. Tell this to a high school student. All this. He will say, "Oh my God, why did you shut up, please?" We need to find ways to tell people, students, that maybe there is another way for you, for everybody to get these things, to enjoy these things instead. Find a way for everybody to enjoy this. And now look at this. The circle is a blank. Okay. A radian is a circle of radius. Okay. Cool. And now we have the equations. And we have coordinates. And we have the equation. Where there is a triangle. Still, and look at this. This looks promising. We have the origin and maybe draw some triangles. um, Also, if we want to, like 90 degrees, we should draw this triangle. Find this point, which is radius um, 2x and radius 2. Some radius, this is a right triangle, like some radius to the left, right on the x, and some radius to the minus y. How will you know that? This minus y. The thing, we need to find some unified formula because if it is 45 degrees, we will have this is, so the thing is not uniform. Uniform, right? Now we don't know that. We need to find some sort of unified formula. Maybe I'm just telling nonsense. I'm ignorant. Uh, well, okay. The circle with center coordinates AB and radius r is the set of all points x, y such that uh, apply to any point of the circle. We will need to solve this. If the circle is centered at the origin, then equation simplifies. Okay, this equation is for all the for any given point in this curve, on this curve. What if you have this? If we continue scrolling, we will find maybe the solution. We don't want that. For the time being, let's take a look at geometry, you know, and then we will look right using Google. So how I can, uh, what's the equation for some sort of rotation? So we have center. Yes, we have. Maybe we can use this. Maybe. Uh, how you can include the rotation in on this? Well, you can include the rotation. This is not. It will not be a straightforward. Uh, you know, maybe I will need to refresh some algebra first. Do some exercises on circles. Some book available on the Internet Archive, which I can document for you. Uh, yes, yeah. So do your thing. Don't hate mathematics. Don't be afraid of mathematics. Listen to this guy, Leslie Lamport. Yes, again, this guy. So he says, like just learn some high school mathematics. It doesn't have to be esoteric mathematics. My God, I think we software engineers should be reminded of this thing on a daily basis. Uh, this is a lot. This is a lot. Circle of Apollonius. or radius, locus. This is on this. This term is on the book. So let's suppose, yeah, we have to. What can we do with this? So what actually this thing says? If you're not a mathematician and you are presented this equation, and this refrained me from reading books, mathematics books, the ones I have accessed in the past. I was unable to extract information from these things. I didn't understand the language of mathematics, and I still don't understand it. But so I was reading all sort of books in the past, just skimming books. I finished just some books, just a little, but skimmed a lot of books. But when I was, passing the skimming mathematics books, I wasn't able to extract information from those books. So I was just focusing on the lives of the mathematicians that were portrayed over there. Well, I knew something was there was something in there, but I was saying to myself, I don't understand this, and I put the books aside. I was unable to my brain to get the neurotransmitters that activates from learning. Uh, so I was seeing this thing there. Oh, what does it say here? But now I understand. I still don't understand these things, but uh, the guy is saying that if the thing is at the center, if the origin is at the center, 0, 0, then the equation it goes like x squared plus y squared equals r squared. So what does that tell me? The one thing that I can understand is that the center is here. Then maybe you need to know the radius. Maybe the radius should be a quantity you know. This radius should be known to you, some number. And then given some of the coordinate, if the coordinates solve this equation, then this point belongs to the set of points that are over here. But you need to know this, in my opinion, or maybe or they need to assure you that hey, this point belongs to the circle. Find the radius, and the origin is at the center. Then maybe you can calculate this. but they need to tell you this is guaranteed. This point belongs to the circle, or they need to guarantee to tell you, I guarantee you that the radius is zero. Otherwise, if everything if everything is unknown, then you cannot do that much. Something has to be known, I suppose. Well, that's it. I'm leaving. I hope you guys enjoyed these things as I enjoyed. I'm about to play the guitar. Maybe donate 2 more hours to this project tomorrow. I'm going to save this image. Geometrikap assets. Therefore, there are some existing assets. So we have the problem. We are going to take a look at the book and then some other trigonometry book, maybe some algebra books. And if we cannot deduce the thing by ourselves in a matter of 2 hours, 4 hours, in 2 days, and then we will take a look at the look for the actually for the answer. But when reading the answer, we will know something. We will understand. We will not be on the total darkness. Just uh, you know, we will have something, which is great. So good night. Good night. Let me see if you so the people. And we have one live viewer. So thank you. If you know this stuff like the palm of your head, of your hand, you write a comment. Oh, we have the likes, 100%. This is great. Oh my God, I feel like, oh my God, thank you very much. Yeah, if you know this, say, Caleb, my God, you are ridiculizing yourself. Come on now. This is the answer. Stop wasting our time. Move on. Uh, you can take it from here. Put it on the comments. Put the equation or whatever you want to write. I would appreciate it. But yeah, 2 likes. Great. This is the first video that has likes. Oh, we have another like here. We are working. We are not working for like, but we appreciate the likes. This is just, one like viewer. Have a good night. We are finishing this stream tomorrow. We will be devoting 2 hours. I hope you get online. The people that were here, get online. Stay tuned. Have a good night. And thank you very much. Bye.